Welcome. In this video, we're going to look at another reaction of carboxylic acids, or a couple of reactions, and that's the reduction of carboxylic acids. And I'm going to look at two types of reductions that we can have and an example of each. And the first one, we're going to take a carboxylic acid and turn that into a primary alcohol. And so this is going to be the opposite of an oxidation with potassium dichromate and sulfuric acid, which would take a primary alcohol and oxidize it all the way to a carboxylic acid. So, we'll kind of call this method one. And so the general reaction here is we're going to take a carboxylic acid. Okay. And if our reducing conditions are a strong reducing agent, such as lithium aluminum hydride, LiAlH4, followed by H3O+, okay, so a workup step here. What that will ultimately give us is we're going to reduce this all the way to an alcohol. Okay, so we're going to lose that oxygen and we're going to replace it with two hydrogens. Okay, let me give you an example of what this would look like. Let me give you a primary alcohol. All right, so this is, I'm sorry, a carboxylic acid. We're doing a reduction here. Okay. 1, 2, 3, 4, 5. So pentanoic acid. We could take that, and if we used lithium aluminum hydride and H3O+, that's going to reduce this carboxylic acid 1, 2, 3, 4, 5 to an alcohol. Okay, so the key thing here is we're changing the functional group from a carboxylic acid to an alcohol, and we're not changing the number of carbons. Okay, and we're reducing all the way to the alcohol oxidation state. Now, there may be situations when it's not the alcohol we want, but maybe the aldehyde oxidation state. And in that case, we're going to use a different strategy. So method two, what we're going to do is first we're going to form the acid chloride. Okay, so we're going to take our carboxylic acid again, and then the first thing we're going to do to it is we're going to use thionyl chloride, so that's SOCl2. All right. You might remember this reagent. We used it before in the chapter on one of the chapters on alcohols to turn an alcohol into an alkyl chloride. Okay. We can also take a carboxylic acid and we can turn it into an acid chloride using SOCl2. And in a future video, I'm actually going to go over the mechanism of this transformation, because this can be a really useful strategy to getting to various carboxylic acid derivatives. Okay, but for now, we're going to use it to get to an aldehyde. Okay, so this acid chloride is very reactive. So what we can do now is we can use a mild reducing agent on the acid chloride, and that will get us to the aldehyde. Okay, and the one that tends to be used for this reaction is lithium aluminum, and then there's one hydrogen, and then triterbutoxy. Okay, aluminum hydride. Okay, and what that looks like, I'll put that in here. We've got the lithium counterion there's our H. So this is going to be the equivalent of H minus. Okay. And then we've got 3 oxygens attached to that aluminum with 3 bulky tert-butyl groups. And so this structure serves to make a less nucleophilic and less basic hydride species. Okay, and so that allows us to stop at the aldehyde oxidation state. Okay, right there. Okay, so let me give you an example of this. Let's say I had this primary alcohol. All right. If I took that and had a first step that was thionyl chloride, SOCl2, and then a second step where we use our mild reducing agent. Oops. T-butyl. That's going to take us to the aldehyde. Okay. And again, we're not changing the number of carbons. We still have 5 carbons. Okay. And then if we were to, oops, and I'm sorry, we're starting from a carboxylic acid here. So this transfers us from a carboxylic acid to an aldehyde. Whereas if we had used the stronger reducing agent, lithium aluminum hydride, followed by a water workup, that would take us all the way to the alcohol oxidation state. All right, and that's going to conclude today's lecture on 2 types of reduction strategies of carboxylic acids. Thanks for watching.